Welcome to H2O Driverless AI. This is the login screen. Logging in will take me to a screen where I can add a data set from a number of sources. We are continuously adding to this selection. The first step is to import a data set. We are going to be using the credit card data set from Kaggle. Once the data set is imported, we can do a number of things. I can intelligently split my data. Here, we'll specify the names of the two data sets we're going to be using, CC1 and CC2. I can choose the percentage of the split that I want to use. I'm going to be using 80 and 20% split. You can now see that the data sets have been created. This is useful if you did not already have test and train split ahead of time. You can generate these on the fly in Driverless AI without having to use other software like Python or Spark prior to ingesting it into Driverless AI. Once I have my dataset, I can use the AutoViz tool to automatically visualize the dataset. It will generate interesting plots based on the datasets provided automatically. I can navigate through the various plots via the carousel. This particular plot is identifying outliers in each column, which I can highlight, select, and analyze. Other interesting plots include a correlation graph, heat maps, etc. The correlation graph shows correlations amongst variables, is interactive as all of our visualizations. In our credit card dataset, we can see a high correlation between bill amount 1 and bill amount 2. I can use the help button if at any point I do not understand what a visualization represents. I can download any plot for later use. Once I'm done visualizing a dataset, I can create an experiment by simply clicking Predict. We will need a train dataset and optionally a test dataset. For our data, we'll be using a target of default payment next month, trying to determine if a customer is going to default on their payment on the following month based on their payment history. With the trained data and target set, you will be presented with three knobs dictating how you prioritize accuracy, time, and interpretability. Changes to the dials will be reflected in the panel on the left-hand side. Fine-tuning of an experiment can be performed from the export settings. I can require certain algorithms or turn them off. I can set certain values, whether or not to build the Python scoring pipeline, whether or not to build the Java scoring pipeline after the model is completed, etc. We will start the experiment with the default settings. Now, driverless AI is intelligent and recognizes that an ID column is present and automatically drops it. The upper left-hand corner describes the dataset. This particular dataset has 24,000 rows and 25 columns. The upper right-hand side are my settings relative to accuracy, compute time, and interpretability as previously defined. I am able to see real-time metrics of the model being created, different charts, ROC curve, precision versus recall, lift and gains chart, KS chart, and you'll also be able to see your actual resource consumption, CPU usage, memory usage, GPU usage if the machine has GPUs as ours does. We can see that with each iteration of the experiment, new models are built and tested. We can see the variable importance of the model right here. When the experiment is done, you'll receive a screen that looks like this, where typically the final model is the best model. You can do a couple of different things. You have the option of scoring on another data set, transform a dataset, download the predictions of both train and test datasets, download a scoring pipeline in Python, download a scoring pipeline in Java, or download the experiment summaries and logs. The experiment summary has something called the automatic documentation. It is an automatically generated document that will show you exactly what we did over the course of the experiment and why we did it. You can see the settings that we chose, the environment that it was running under, version of driverless, the data that was selected, so on and so forth. Most importantly, it shows the details of what we decided and what parameters were used for the model, which can be very useful, especially when you're trying to prove that this model is production ready, or maybe bring this to your executives as a part of the explanation for why this model is useful. For model deployment, you have two options: the Python scoring pipeline, which is significantly better for batch predictions, or the Java Mojo scoring pipeline, which is great for real-time scoring. You can also diagnose this model on a new dataset. This is very helpful in lifecycle management. For example, as more data becomes available down the line, you can actually click on Diagnose Model on New Dataset and see how this model performs against the new dataset. When I interpret this model, I'll get a screen that looks like this. It is a summary page with plain text explanations of what the MLI process did. You can also look at feature importance and Shapley explanations for the final model generated by Driverless AI, or the surrogate models, which are proxies for the final models created by Driverless AI. For example, K-line, decision trees, and random forest feature importance, partial dependency plots, etc. You can also download any necessary resources from the Resources tab, including the Python client, so that you can interact with Driverless AI with Python. We can also create automatic one-click deployments to compute platforms like AWS Lambda, EC2, local REST server, etc. Based on your experiments, you just have to provide the proper credentials. We entered Driverless AI in a Kaggle contest. This was BNP Paribas Claims Management Prediction Kaggle contest. In a more complicated model, we can see that I'm able to get Kaggle level results on a dataset that was 114,000 rows and 133 columns. After running for a little over 6 hours, I was able to generate 17,000 new features and train 3,000 models. Had I entered this competition, I would have placed in the top 1%.